Hello everybody and welcome back to the Java programming course. This is lecture number 9. The topic is abstraction in Java. So abstraction in Java. So first of all, what is abstraction? So abstraction is the process of hiding certain details and showing only the essential information to the user. So basically, we are hiding the inner workings of how a thing is working and just showing the user the result. So for example, if you want to drive a car, then you don't particularly know like the specific things that happen while driving a car. You just know that you have a steering wheel, and if you go left, then the car will go left. You don't know the inner workings of the car. So that is abstraction. The user doesn't need to know how the thing works. The user just needs to do the work. So that is abstraction. So abstraction can be achieved with either abstract classes or interfaces. So we'll now look into both of these one by one. The first are the abstract classes in Java. So abstract classes are special type of classes. So an abstract class must be declared with an abstract keyword. So let's just go to the lecture, and we can do this in IntelliJ by this. On your package, just right click, new, and Java class, and just normally select class, name whatever you want. So we'll just do ABS as abstract, and here you have to put the keyword abstract. So now by putting abstract keyword here, the class which is ABS abstract now is abstract. So this is the first point. Then it can have abstract and non-abstract methods. So just like classes, methods can also be abstract and non-abstract. So so an abstract class can have both abstract methods as well as non-abstract methods. We'll look further into what are abstract methods. Then one of the main things is abstract classes cannot be instantiated. So what does that mean? Let's say from main, like when we used other classes like car here, then from main we could just create an object of it. So car1, and this was perfectly fine. So but in case of abstract classes, we cannot make an object. So if we try to do this, let's say abs yes is equal to new abs, which is how you normally make an object, and if you try to run it, it will show an error. You can already see there is a red line coming below this, which will give us an error. If we try to run it anyway, Java shows an error because abstract it is ABS is an abstract class and thus cannot be instantiated. So this is one of a very big difference in abstract classes. You do not you cannot instantiate an object of an abstract class. So remove this. Then the next point is it can have constructors and starter methods also. So constructors normally, just like how we created in normal classes, we can create the same for abstract classes. So just do public ABS, and within this we can just say s out and write ABS class. Yeah. Okay, so this is done. We can have constructors, but once again, we cannot directly create an object of ABS class itself, so this constructor won't work in that way. And similarly, so we can have static methods too. So if we try to create a static variable here, so static int a equals to 5, then this is perfectly valid. So abstract classes can support static numbers. So this is it. Then abstract classes, it can have final methods which will force the subclasses not to change the body of the method. So we can create final methods. So final void func, and here we can just do a method like s out func call. So this is a final, so it cannot be changed. So if we when we make a child object, and if we try to change this function, we cannot do so. as final way finalize this method. So these were the main key points to keep in mind while working with abstract classes. Next comes the abstract methods. So what are abstract method? Abstract method is and how to declare it. So just like classes, abstract methods are used to hide the inner workings from the user. So and how do we declare it? We make an abstract method just by using the same keyword, which is abstract. And one thing to keep in mind is that it does not have any implementation. So if we just do here abstract method, abstract void func2, we cannot do anything within this. If we try to say hello, it is showing an error. We cannot do anything, so we have to keep this empty. We have to do this. So this is the way to make abstract methods. So you do not do the implementation within this. To implement this, we have to make a child class, and within that we can override the method function too, and then we can use them. So this is how to work with abstract methods. So this is an example. So abstract class bank. So we create an abstract class which is named bank, and it contains abstract method, returns an integer data type, and the name is get rate of interest. Keep in mind here the method declaration is like this: method name, the brackets, and then semicolon to end it. Normally we don't use semicolons in declaring normal functions. We use the curly brackets like this here and here, but here for abstract methods we use semicolon just like our normal lines. Then we create a normal class SBI which will extend bank. So a child class is inheriting from this abstract class. So bank, and here within this child class now we override the method which was get rate of interest. So it will return 7. Similarly, if we have another class PNB and do the same, we can similarly just override the get rate of interest method. So this is our main class here, test bank, and when we do this, we we initialize bank B. Sorry, yeah. So we do bank B, but keep in mind we do not do is equal to new object. So this is the main class test bank. So we make bank B. Now keep in mind we cannot do B is equal to new bank, but we can do B is equal to new SBI because SBI is not an abstract class. If we try to do B is equal to new abstract, if we try to do B is equal to new bank, then we get the error I just showed you. So we make B as an SBI as an object of class SBI, and if we just to print out rate of interest is b dot get rate of interest, so what it will return is this, which is 7, and similarly for PNB it will return 8. So this is an example implementation of abstract class and abstract methods. So next comes the interfaces. So interfaces are special type of classes, and it is basically everything is abstract in interfaces. So an interface in Java is a blueprint of a class. It has static constants and abstract methods. So basically everything is abstract. You don't have to put abstract keyword uh, everywhere. So if you want to make everything abstract, you simply use an interface. So one of the very crucial things about interfaces is you can use it to achieve abstraction and multiple inheritance. So we earlier in a previous lecture discussed that multiple inheritance was not supported in Java, but using interfaces we can do so. We'll come into why. And an interface is a completely abstract class. As I said, everything is abstract and it's used to group related methods with empty bodies. So these are classes and interfaces. Here a class can extend a class can extend an interface, and interface can a class can implement an interface, An interface can extend an interface. Keep in mind that implements is the keyword used to implement an interface. For extending class, for classes we use extend, but for interfaces we use implements. Also, an interface cannot extend a class, cannot inherit from a class because of the basic structure of interfaces. So how do we make an interface? Let's go to IntelliJ. So from your package, just simply right click, new and Java class. Here instead of selecting class, we keep in mind that we select interface. Now name your interface. Let's just do uh, so in test. So this is an interface. So here you can see the keyword interface is used. So to declare, so everything is abstract in this. So to create a method, do public void func1, and just do f1 and simply close it. So you cannot declare anything within this because this is an abstract method kind of. So you do not implement it within the interface itself. You just make the function. So you are basically declaring it, but not writing the implementation. Similarly, we can make other methods. F2 also, like public, make private also. Private int f2, and this is perfectly fine. So we have to return also because it is an because we are returning integers. So we do not do anything else here. We just simply returning 0. So these are now, and these when the class implements this. So let's make a class which will implement it. So new Java class to implement. So this is a normal class. This is not an interface, and to implement the interface, we use the keyword implements followed by the name, which is in test in our case. And now what we have to do is from the function here, from the interface here in test, we created two functions f1 and f2. So we have to do the implementation within this child class. So just copy this as it is. So Control C and Control V, and now within this we use the curly brackets and make our implementation. So s out f1 called. Similarly for f2, C, Control V, and we can do s out f2 called. So this is how you make and implement an interface. This is an interface and this is a class. So the main thing to keep in mind is you do not implement the method within this interface. So if we try to make another interface, let's say package, let's do interface 2 int test 2, and if we want to make the same function, so we'll come to why multiple inheritance can be done using this. So here we made the same exact function f1, same, and return type is void. And if you try to do this here, if you try to implement this also here in test2, this is perfectly fine. See, no error. So what is the reason? So we have to understand we did not support why we did not support multiple inheritance in case of classes itself. So the reason was that if you wanted to inherit properties from class 1 and class 2, and both have different definitions of the same function, then the child class cannot know which implementation to follow. But in case of interfaces, we can clearly see that we do not define the implementation within the interface itself. We are just simply defining the function name. So here F1 is created, but we do not implement it. Similarly, here F1 is created, we do not implement it. The main implementation is done within the child class itself. So thus, our child class has no problem in knowing what function, what to call in case we try to call F1 to an object of this class, because it will call whatever is inside this declaration. We did not declare it here, we did not declare it here. So this is why multiple inheritance is no problem and can be done using interfaces. This comes in very handy and one of the very key features of interfaces. Yeah, and also why we cannot do here, let's say in test extends and let's say car. Okay. We cannot do this. It's showing an error. So why? Because the definition, sorry, the methods has to be just declared and not implemented. And if we try to extend car here, so what extending does is basically gives all these properties to this class as well. So basically what we're doing is we are giving this function, this function, this function, all these functions to this interface. And what's the problem? These functions are implemented. These are not simply closed. And we cannot have such functions, these methods in an interface. So that is why an interface cannot extend a normal class. So if we try to close, so this is wrong. But we can do an interface can extend another interface. So this is fine. So because these are also not declared, these will also not be declared. So one can it can inherit f2 as it is not declared. Int s2 can have f2 because it is still not declared here. Only the child of int s2 will be declaring the implementation of f2 function. So this was interfaces and classes, how we use them in combination. One can classes extends class, class implements interface, and interface extends in the other interfaces. So here's an example of interface. So we make an interface and name it bank, and we create an object float. We create a variable float rate of interest function. So this is a method here, rate of interest, returning a float. So if you try to, so this is a class SBI and it is implementing from bank, implements not extends, implements from bank, and now we implement the function. So public float, rate of interest, and return. So here we just simply ended it with a semicolon, but now we will properly do what we have to do using the method. Similarly for PNB, now we can have a different implementation. So in this case, we're returning 9.7. So this is our main class. In this example, we make bank B, new SBI. We cannot instantiate an interface, so we instantiate a normal class, so SBI, and then if we do B dot rate of interest, it will return 9.15. So this was it for interface and abstract classes. So difference between them. So first of all, abstract classes can have abstract and non-abstract methods, but interfaces are special type of abstract classes and can only contain abstract methods. Then abstract classes do not support multiple inheritance, but interfaces do support multiple inheritance as I showed. Then abstract classes can have final, non-final, static, non-static variables, but whereas interface can only have static and final variables. You cannot have non-final or non-static. So then abstract classes can provide the implementation of interface, but interfaces cannot provide the implementation of abstract class. So using an abstract class, you can basically make an abstract class into you can make an abstract class work like an interface by just simply making everything abstract. But you cannot do the same in the reverse as an interface. So you can say that interface is a special abstract class, while abstract class is not a special interface. So one-way relation there. Then abstract classes, it can have methods like private, protected, etc. But interfaces, members of Java interface are public by default. So this was the difference between abstract class and interface. So interface are just a more concentrated form of abstract class. So this was it for this lecture. Hope to see you in the next lecture and wish you happy learning. So goodbye.